Today we're doing 11-2, more with the inverse variation. So the first problem, so look guys, this is what the graph of the parent function looks like. Okay? The parent function y equals 1 over x looks like this. Okay? So, the first problem says, graph each function. Well, if you do 12 over x, it's going to look very similar to 1 over x. I don't care if y'all draw the graphs on here or not. You guys should be using your Desmos or whatever you downloaded on your phone. Graphing calculator to see what the graphs look like though, so you can get more used to understanding what's going on. Okay? But for these, what I really am after is identifying the x and y intercepts and the asymptotes, and then the domain and range. So, let's look at x and y intercepts. So, if you remember, for the x-intercept, you're going to put a 0 in for y. So x-intercept. 0 in for y. And for the y-intercept, 0 in for x. Okay? So, let's do that. So for the x-intercept first, on number 1. So we do 0 equals 12 over x. Okay? So there's no way that this can ever be 0. Okay? I know some of y'all are probably thinking, oh, well, if x is 0, it's 0. And no. Okay, you can never divide by 0 in math. So there's no way 12 divided by any number is going to ever be 0. So then there is no x-intercept. Okay? And if you look at the graph, that makes sense. Because on this graph, it's never going to touch the x-axis. So, no x-intercept. What about the y-intercept? Well, for the y-intercept, we put a 0 in for x. Uh-oh, I just told you. You can never divide by 0 in math. That is a cardinal sin in math. So we don't do it. Okay? And so if you divide by 0, that right away. No. Y-intercept. Okay? And if you look at the graph, my graph turned off, but if you look at this graph, it never touches the y-axis. Okay? So, no y-intercept. Now, when we look at asymptotes, the asymptotes is anytime you have a 0 in the denominator, you get an asymptote. So, right here, when x is 0, so x equals 0 is a vertical asymptote. What about the other one? Well, you can't have 0 here either, can you? Because there's no way to get this to equal 0. So, y equals 0 is a horizontal asymptote. Okay? And then domain and range, well, if you look at the graph over here, where does this exist for x? Remember, x is domain. It exists everywhere except for 0. Because there's a asymptote at x equals 0. So domain is all real numbers. X cannot be 0. What about the range? Well, it's the same thing, right? It's all the numbers. If you look at the graph, it's all the numbers except for 0. So the range is also all real numbers. Y cannot be 0. Okay? So y'all need to do the other two. So on this one, all I want y'all to do is take your graphing calculator you downloaded on your phone, okay, and graph y equals 1 over x, and then graph this in for A, and see what the differences in the graphs are, okay? And then just describe that right here. All right, and the next one, it says sketch the asymptotes in the graph of each function and identify the domain and range. Okay? So what you're going to do is, you're going to graph these on your calculator, and then you're going to tell me the domain and range. So let's look at the first one. Okay, the first one is y equals 1 over x plus 3. So up here at 3, there's a horizontal asymptote. And then right here on the y-axis, there's a vertical asymptote. And it looks like this. Okay? So that's all you got to do is draw the graph. Okay? The asymptotes, just use dotted lines for the asymptotes. Okay? And then finally, just domain and range. So the domain here would be all real numbers. X cannot be 0, where the asymptote is. And the range would be all real numbers. Y cannot be 3. Okay? So you're going to do the same thing for those. We've been dealing with domain and range all year. Y'all should not have any trouble with domain and range. Okay, so now you're making an equation of this original one that has these asymptotes. Okay? So, all you need to do is shift the graph around a little bit. So, here's where knowing the transformation stuff we've done all year really helps. So, y equals -3 over x, and asymptotes at x equals -1 and y equals 3. Okay, so this right here, this one's easy. All you do is move the graph up. So you add a number over here. So y equals 1 over x plus c. C is vertical or horizontal asymptote. Okay? And then y equals 1 over x